that handout I gave you. So some of this just screams it's going to be multiple choice. Okay, so you might want to take a look at the answer key for your Unit 1 exam, okay, and be familiar with, what matter is, has mass, occupies space. The physical phases of matter are solid, liquid, gas, that sort of thing. And we talked about kind of nuances of solid, liquid, gas. Gas has most kinetic energy, solid has least kinetic energy, that sort of thing. So those could be possibilities. Then the next two things there, these two things, let's see, right here. Okay, we talked about kind of a logic tree of matter. Matter can either be a pure substance or it can be a mixture. Okay, so types of mixtures are homogeneous, heterogeneous. Oops, that isn't what I meant to say. It looks like elements or compounds, those are examples of pure substances. This thing, mixtures versus pure substances, kind of the initial breakout. But remember, mixtures, we said there's two types of mixtures. There's homogeneous and heterogeneous. Okay. Just to kind of, and I wouldn't put that on your note card necessarily, just to kind of remind you what it is. Okay, we spent some time talking about physical versus chemical properties and changes. Remember, chemical change is one where new substances are formed. Metric system, okay, so those, remember, I said there are 4 prefixes you need to know. They are K for kilo, C for centi, M for milli, and micro, and mu for micro. Okay, so those are the 4 prefixes you need to know. Kilo is 1,000 times the base unit. Centi is 1/100th. Milli is 1/1000th. And micro is 1/1,000,000th. Okay, so we talked about those prefixes, metric system. Scientific notation, okay, just remember how we talked about scientific notation when you guys have been using it. Then the whole rounding, okay, significant figures. Rounding according to significant figures if you're multiplying or dividing. And if you're adding or subtracting, you round according to decimals. So I'm running out of room to put that. So rounding. And you guys are doing pretty good. But especially, just know how to round. If you're adding or subtracting, you round according to decimals. And if you're multiplying or dividing, you round according to sig figs. All right. Factor label and unit conversions. That's a big one. Especially in the last part, and I think I will say this on your final. I think your final says this. You must use the factor label method. Must use FL, method, when you go to show your work. Density is, we did a lab about that. Density, remember the symbol for density is the Greek letter rho. I'm putting up at the top there. Density is a ratio of mass to volume. Mass percent is a, let's see, I'll put that one right here. So mass percent is basically you take the mass of the component, and it could be like a shell or the white or the yolk. I'll put COMP for component, okay, divided by total mass. In the case of the experiment we did, that's the total mass of your egg. Energy and energy changes, oh yeah, we did do that. Remember Q is equal to MC sub P delta T? I'll kind of lump all of these together here. Q, change in thermal energy, is equal to the mass that's changing its energy times the specific heat. You look it up on a table, or you're given it. Delta T, and that is the change in temperature. And if you look back at your, if you opt to look back at your old tests, you're going to see a problem like that. Okay, Unit 2? Okay, so actually I told you I was going to look at these and see if anything pops out at me, like they'd be good problems, you know, those last 8 problems. Some of that conversion, like factor label and unit conversion, that could be a problem at the end, okay? Actually, even density could be a problem at the end. If you're wondering what the problems would be good like at the end, look at the end of all of your unit exams. That's the sort of problem, okay? Remember, those are under doc sharing. Mm-hmm. Mark it up. Mm-hmm.
I need to do the last test.
It's a work of art. Any questions about that? Full sheet, Xerox copy of periodic table if you
I even
want.
have a little key down here that tells me alkaline metals.
It's color-coded, yes,
Yeah.
yes, yes.
Tells me everything. I just looked up printable. You have to look up printable ones on the internet though if you want one, because the other ones you won't be able to read anything when you go to print them.
Okay, very good. Good suggestion. Printable periodic tables.
Yeah, has to be a printable one.
But the one thing I am going to be looking for is you cannot just take somebody's and Xerox copy it. Xerox copy a periodic table, I'm going to put in red, cannot Xerox copy,
Like running it through the copy machine.
yeah,
and just
copy
the same one as the
someone
original.
else's.
Like I couldn't copy mine and hand it out to people.
Right, right, exactly.
There was my plan.
Oh, and related to all that is you're going to turn in this page we're talking about, turn in page with exam. So, I mean, I'd be able to tell if you just like Xerox copied somebody else's. That's not what I'm.
Do you know like
trying
when
to
we'll be able to look for like our final grades, like to know they're finished?
Well, I have back-to-back finals on Monday.
Goodness.
Yeah. So, but Tuesday I'm hoping to knock out some of that stuff. So Tuesday afternoon would probably be the soonest,
Be the
and it
same.
might
So,
be
like,
Wednesday morning. Yeah,
That's fine.
yeah. It'll be posted in the grade book.
Yeah, we'll be able to see like what we got on it.
Right. And you can actually come by my office and see what you missed, you know what I'm saying, or what you
Yeah,
got
I've
right.
done that before. On,
Yeah.
like, some of my
I can't give it to
stuff.
you to take home because I reused my final exams. But,
You can look
yeah, so any questions about that? That's a good question.
We
So-
covered a lot on gases.
What's that?
I was-
We could cover a lot on gases.
There will be, so I can answer it this way. Oops.
I knew we had, there was a page you didn't have, and I tried to look on the Twitter feed, but it cut half of it off, like the screenshot that showed up on your Twitter feed for like, you know, the thing that you've been posting about like what we're doing in class and then
Like the
what finals.
announcements?
It kind of cuts some of it off, like when you click on the picture. It
Okay,
doesn't
I'll
show
kind
the
of
whole
look at
thing.
that. So is this what it cut off, the whole, I'm gonna just add another picture. The content of the exam will be 25 MC, stands for multiple choice questions, okay? And you don't have to show your work for those. But in there, I think there's a gas law problem. And each of these are worth 2 points each. Okay, so there's 50 points there.
Whoa.
Yep. And I'm going after 100. So actually, the next part, is that right? Yeah, 50, 48. Maybe. Oh, I'm thinking there might be 26. I'm thinking there might be 26 here. 26 multiple choice questions, because then it makes it worth 52 total. And then your other section is worth a total of 48 points. Okay, so this is where you need to show your work.
Those are like the math problems and stuff.
Right. And there are some math problems in the first part too, but they're just multiple
There's
choice.
multiple choice, you don't have to show your work. These ones we have to show.
Yep, show your work. And there's, let's see, it looks like 8 problems. 6 points each. And just this semester, I'm trying this out, there will be another problem tacked on to your last section, and it will be a gas law problem. Okay, so 1 extra problem. And
If there's just one, you should make it crazy, ridiculously difficult.
no, it's gonna
And
be,
everyone's like, come on!
it's gonna be a gas law problem, 1 extra problem, and it'll be 6 EC points. So extra credit points. Okay,
And the 8 problems are gas problems or gas.
no, the 8
Oh.
problems, and we'll see those in a minute, when we go through this here. Okay, I'm gonna maybe like show that that'd be a good problem, that'd be a good problem. They're like, it's comprehensive final, so it's stuff we've done all semester long,
Okay.
yeah.
Is everything like separated by the units, or is it just all mixed together?
It's all mixed together, yeah. Yep, it's a hodgepodge, just like our brains. Okay, any questions about the test? That's kind of what it's looking like. So there will be a gas law problem worth 2 points, and then there'll be an extra credit gas law problem.
And the 8 problems, those aren't gonna be, or those aren't gonna be like multiple choice or anything like that. Those could be.
Right, the 8, and that's what I think might be helpful, and because I can't remember the final, even though I've used it many times, but I'm gonna go through this and kind of say, oh, that would be like a sort of problem, would be worth 6 points at the end, that sort of thing. Okay? All right, so, but in the meantime, let's take a look at, so on to what we talked about in Unit 2, the periodic table, yay, right? Okay, so especially if you go ahead and take, bring a periodic table that has the names, that'll help you, you know. Let's see. We talked about groups. Let's see if this is on here. We talked about 1A is like the alkali metals, 2A is alkaline earth metals, so know those names of groups. And if you go ahead and dress up your own periodic table, you can write the names of the groups at the top of them. Heck. Simple atomic theory. Not sure what I'm after there. Oh, that was like Dalton's atomic theory. Might want to take a look at that. I'll just put Dalton's AT for atomic theory. So that make that easier to be direct. The next one, the whole 3 subatomic particles. You might see questions about protons and neutrons and electrons. Kind of on that unit exam, I asked you questions about those. So be sure you kind of know that again. The atomic number, of course, is the number of protons. And the symbol is, it drives me nuts, the symbol actually is Z for the atomic number of protons. Okay, and that says, we talked about the number of protons in the nucleus of an atom, says what kind of element that atom is. The mass number is protons plus neutrons. Okay. And remember we said that actually neutrons, and that's the next topic up here, neutrons, I'm going to put a question mark. Neutrons actually are not in stone for a particular element. Well, they are, but they aren't. And as an element has the same number of protons but varies in neutrons, then we get isotopes. So isotopes are neutrons vary. Average atomic weight, that was actually one of the problems. I'm not sure if it's on your final. It's been a year since I looked at your final. But remember how you guys came up with average atomic weight? by summing for each isotope. There's this little formula that sigma means sum the mass of the isotope times its abundance. It's fractional abundance, and you added them all up. But average atomic weight, it's kind of important that remember that actually is the decimal number. I keep calling it the decimal number. Decimal number for an element in the box in the periodic table, and it's in units of AMUs. The atomic number, I'll go ahead and go back up here. The atomic number is the whole number. Whole number. It's WHOLE. Okay, on the periodic table. Then, oh, one other thing you probably, the next line, going to the next line, the mole and molar mass, you probably want to write down what a mole is. So 1 mole, of course, is equal to 6.022 times 10 to the 23rd of anything. Molar mass, then, is something different. It kind of gives it away. If you focus on the mass part of molar mass, the molar mass, which we affectionately call MM, molar mass, is grams of the substance per 1 mole of the substance. That's what molar mass is. And molar mass is the same as the average atomic weight for the elements. So it's the same number, but instead of AMUs, it's grams per mole. So these are things that you've been using. Then we talked about electrons, and actually the next 3 things kind of go together with regard to electrons. The Bohr model of the atom says that basically electrons reside in energy levels, or hang out, reside in E levels.
If something was extra credit, like on one of our tests, do you think it would make it onto like the final?
Like what? What was it?
Like, we had 4 points extra credit on the first.
Was that the Q is equal to MC sub P delta T?
Yeah.
Your point is well taken. I'm not going to commit one way, but I doubt it, but I can't remember.
Okay.
But your
Well, I just wondered,
instinct is
since we
right.
had it on extra credit for
Right.
one test, then it wasn't something that we had to do for a normal test. I didn't know. if
So would
we
it go
needed
to
know.
an annual
Yeah.
comprehensive exam? So I'm not going to commit, okay?
Maybe.
Because I don't want to mislead you, but I think that seems reasonable to me. Yeah, that was Unit 1. She's at the end of Unit 1, I had the Q is equal to MC sub B delta T. So electrons, remember how that whole thing works. One of the things here I'm going to write down is I would, if I was you, write down your arrow diagram. In Unit 2, that was worth credit to write down your arrow diagram. And it's not going to be credit here, but you should write it down in your thingies. You'll have room, the thing you're going to bring the sheet. I would write down your arrow diagram. Remember and know how to use it. Arrow diagram will tell you how to come up with how electrons are configured. Remember, like for instance, if we pick on something simple like carbon, we came up with carbon has number 6, so it has 6 protons and 6 electrons to find homes for. And remember this, we did 1, S2.
it increased it as it went right.
Yeah, it increases from the right back to the left
Yep,
again,
and then
and then
down.
increases down, yep. You can throw that on your periodic table too. Or on your
Another
thing.
one that goes right, and I think it's electronegativity.
Yeah, it is electronegativity. Yeah. Speaking of electronegativity, so then this was the one where we talked about compounds, and compounds, of course, are where atoms join together. And we talked about two different ways atoms can join together. We talked about atoms joining together with a covalent bond, and atoms joining together with an ionic bond. And covalent bond is electrons are shared, and ionic bond is electrons are transferred. That's TRANS.
say that one more time.
Sure. Covalent bonds, electrons are shared, and ionic bonds, electrons are transferred. And there could be a multiple choice sort of question. I can't remember. Remember on this unit exam, I gave you examples of compounds, and I asked you to tell me whether they were ionic or molecular. And so that's kind of this topic right here, ionic versus molecular compounds. So I'm just going to say ionic, okay, look for the metal. So look for the metal. And I guess this goes back to the previous unit when we talked about the periodic table. Do you guys remember how to identify the metal with the JAG? Draw on the JAG or find the JAG on the periodic table. And then this is stuff over here to the left are metals. Yep. And electronegativity. Let's go ahead and write the trends up there in the upper corner. So now electronegativity increases from left to right, and it increases from bottom up. And the symbol for electronegativity is that Greek letter chi, so it looks kind of like an X. Electronegativity increases that way. But maybe more to the point, electronegativity is an atom hoarding electrons. Atom wants to hoard electrons. How do you spell hoard? We're spelling like that. Okay. And then ions, this could be a multiple choice sort of question. Remember vocab, I asked you like, what is a positively charged ion? It's a cation. A negatively charged ion is an anion. So I'm just going to go ahead and put plus for cations, and I'm going to put negative for anions. Okay, so probably, you know, some of the stuff hopefully you're kind of just remembering. And with the plus, I'm going to put metals tend to form cations. And I'll go ahead and say metals lose electrons. Okay, and I'm going to say nonmetals over here with this plus charge form anions. And they become negatively charged by gaining electrons. And whether an ion forms to get a complete octet. So what they're trying to do is get a rare gas configuration. That's the reason ions form. I'll say want rare gas. Gas config. So actually that leads into the next thing, where if something loses electrons, becomes a cation, or gains electrons, become an anion, you can write their new electron configuration. All right, sizes of ions. How do I say this? The cation, I'll go ahead and do a plus for the cation. Cation will always be smaller than the atom. Okay, because it's losing electrons. And the anion, I'll go ahead and put a negative for the anion, will always be larger. And I think you guys had on your test to identify which would be smaller or larger. Larger than the parent atom. Oh, then everybody's favorite. Okay, naming ionic or naming and coming up with formulas for ionic compounds. So, does anybody have strategy for how you're going to put on your cheat sheet to help you with this stuff?
Just write all of them
I
down,
don't know.
every one of them, in very, very small print.
Oh, yeah.
All of them?
Yeah.
Yep.
It can be done. And you have
Make that
the
much room either.
and you have the charges too?
Yep.
Because you need the charges, because remember you crisscross and you come up with a neutral formula unit, so I'll just put it like this. You need to be able to, if you're given the name, if you're given the name, you need to be
And
able
I put
to,
an example in front, like-
that's got examples. You need to get the formula. And if you're given the formula,
Like if you're given the name chromium, hydrogen sulfate, and then I like wrote out what their symbol or like was with their charge, and then what it would be when you figured out.
that's so cool. Yep. It can be done. Lewis structures. Okay. Whew. Remember coming up with a pot of valence electrons and then distributing them around your final structure. Okay, I'll just kind of leave it with that. The next one, valence shell electron pair repulsion theory. That's that Vesper, valence shell electron pair repulsion. Okay, and basically that gives it shape. See if this rings any bells. Remember that if you have a structure, what you do is you count sigma bonds and lone pair electrons to know what the shape is. So sigma bonds, that's the primary bond, and lone pair electrons. Okay, count those up, and then you know whether it's, does this ring any bells, whether it's SP, SP2, or SP3?
Like the linear trigonal.
Yep. Exactly. Yeah, you're right. They are linear, just like she said, linear, trigonal, planar, or tetrahedral,
And then like their
respectively.
degrees, like how.
Yep. Yep. And you guys had an example where I gave you the Lewis structure, and I pointed to different atoms, so that sort of thing. Resonant structures. Basically, to me, I just think that they are the same pot of electrons, but you're swinging from different atoms. Okay, so resonant structures are, they differ by where the lone pairs are. By lone pair electrons, where they are. Sigma versus pi bonding, and I'll just kind of next to it say primary versus secondary. So sigma are primary, and pi are secondary. And so, for instance, every single bond is a sigma bond. Every single bond is a sigma bond. But if you have a double bond, you have one sigma, one pi. And if you have a triple, you have one sigma, two pi. Remember that? Let's see. I don't think we did much with bond polarity and molecular polarity. I'm going to draw a line through that one. Molecular weight and formula weight. I'm just going to say add from periodic table, from P table. Okay, so for instance, H2O, you take 2 times hydrogen plus 1 time, yeah. And remember though, that those are in units of AMUs. So if you do have one of those problems, like I think that was a problem for this exam. So it could be one of your 6-point problems, okay? If you do have one of those problems, remember to get your units right and to show all work. So then we said, if you can come up with a molecular weight for a molecular compound, a formula weight for an ionic compound, you then automatically know the molar mass for that same compound. So molar masses, remember, you use the periodic table. But molar masses, like I said a little bit ago, are going to be in units of grams per 1 mole instead of AMUs. And definitely then you can go back and forth, you can use molar mass to go back and forth between grams and moles of substance. Percent elemental composition. Let's see, that was where, for instance, if you have water, H2O, you need to come up with a weight percent hydrogen and a weight percent oxygen. Okay, and so what you do is you take the mass, for instance, for the hydrogen, you take the mass of the hydrogen divided by the total mass. Okay, so, bless you.
Thank you.
So you can see I kind of marked a few things off that we didn't talk about, but you guys had a problem on your test, chemical reactions, like what's the product, what's the reactant, that sort of thing. So P for products goes to form, that's reaction arrow, R, which is reactants. See, those two kind of go together. Balancing chemical equations, you'll want to be able to do that. I think it's a multiple choice question or two, where you have to come up with the coefficients to balance an equation. Okay?
Does that reverse the first one, products to reactants, just the other way around?
Thank you.
Yeah.
Very good, guys. Reactants? No, I was not. Good job. And balancing equations, okay? I will have scratch paper.
So like you'll give us an equation, how will that be a multiple choice?
It will, I think the multiple choice says, gives you like, you know how usually I put a squiggly mark, you know, where you put the coefficient. So say there's 3 squiggly marks up there, the multiple choice answers will have like 3 numbers.
3 different numbers and we gotta figure out which
Yeah.
one goes, okay.
Yep.
Takes a lot of guesswork out
What's that?
of it. That takes a lot of guesswork out of it.
Yeah, it does. It does. Some people like multiple choice questions. Sometimes they're called distractors, like the wrong answers, like A, B, C, D, only one's right, and the other 3 are distractors. Sometimes the distractors can be very tricky. Okay, so we talked about how if you have a balanced equation, it's like your recipe, you can go back and forth from moles to moles. This one, actually, this right here is kind of the baby, I'll call it the baby stoichiometric calculation. Because if you read what it's saying is basically you already have moles and you're trying to get to moles. All you need is that middle stoichiometric ratio. That's all you need. But this one is a full-blown, this one right here is a full-blown, okay? And remember what we said, you start with the mass of, I'm going to go ahead and call it known, okay? And you're going to go to the moles of that known using its molar mass. And then you're going to go to the moles of the unknown using a stoichiometric ratio. Just put stoich there. And then you're going to go to grams of the unknown. I'll put mass of unknown. Using the molar mass of the unknown. So that's kind of the pattern that we've been doing.
And that seems like that should be like one of the problems at the end of the test. You'll see one of those for sure. And then kind of related to that, if you get a mass of an unknown, okay, and if it happens to be a product, okay, basically that is your what we call theoretical yield. Okay, because it's what you think you should get back. And so percent yield then is, remember, actual divided by theoretical. Actual, I'll put actual Y for yield, that's an A, divided by theoretical. And a theoretical yield was from the stoichiometric, or yeah, theoretical yield was from a calculation. And then it looks like we have a couple of solution ones. We have solution with regard to molarity and solution with regard to mass percent. Always remember that if you're working a problem with a solution and it has a big M, always remember to unpack. That means moles of something, moles of solute per liter of solution. And if you remember to unpack that when you're going to do your problem, that will usually help a lot. And if your solution concentration is given in terms of mass percent, what that means is grams of solute per 100 grams of solution. That's what mass percent means. And kind of like the Q is equal to MC, so P delta T, some semesters I don't get to spend as much time as we did on the whole, where if you have two solutions and you know the molarity and the volume of one, you know, and you know the molarity of the other, get to the volume of the other. That's the aqueous solution stoichiometric calculations that you guys did. So some semesters I don't get to that as much as I have this semester, so I don't really know if that's on your final. Okay, and then on to the latest unit. Let's take a look. And it looks like this. Okay, so you can see, the characteristics of gases, they're compressible, they fill their container, I guess that sort of thing. Pressure is basically those particles having I don't think you'll do prime pressure. When you do use PV equals nRT, and like I said, you will have, for 6 extra credit points, I'm going to have a full-blown, gas law problem. Just remember that T needs to be in units of Kelvin, okay? And if it is in Celsius, which it probably will be, you get the Kelvin temperature by taking the Celsius temperature plus 273, right? Yeah. Oh yeah, 273.15. Very good. Okay. Don't worry about this next one, the fundamental gas laws of Boyle, Charles, and Avogadro. PV equals nRT kind of has them all. Oh yeah, so this right here, actually this should have gone down here. Don't worry about ideal gas behavior. Wait till Gen Chem 1. We did talk about STP, standard temperature and pressure for gases. The temperature is 0 degrees Celsius, or 273.15 Kelvin. That's the standard temperature, and standard pressure is 1 atmosphere. And then the combined gas law, which you just handed in the homework for that one, that's that P1 V1 over T1 is equal to P to V2 over T2. So your extra credit question will either be, I'm really thinking it's gonna be this one. Alternatively, it could be that one. You'd probably be the first one.
What one did you say, the P?
I really think it's gonna be, yeah, this one, because that's more general than the combined gas law. But I would go ahead and on your note card, if you don't mind, go ahead and write down the value for R. I will probably remember to give it to you, but if I don't, then you have it.
1082058 liters heating over.
Right. Very good, 0.082058, or 7 liters atmospheres per mole Kelvin. Very good. And that's it. I hope that was helpful. Yay.
82050.
That's an 8, yep.
Which one's it? The last one?
Right.
Would you look at that?
0.082058.
Just looking at it.
Going for those A's, going for those A's.
What happened here? Someone quit scratching.